Hi there, my name is Kaya and this is my week 5 performance task. Starting off with the first question, what is the melting point of the substance? So looking at my graph here, I said the melting point of the substance was 55 Celsius. And I believe that because when looking at the graph, you can notice this flat line right here, and right here indicates the melting point. And I know that this is the melting point because this is a flat line. So this was a rising line from 30 Celsius to about 55 Celsius. This is going from a solid to a liquid. So when it reaches this point right here, what this melting point means is that it's coming from a solid into a liquid at this point right here. Number 2, the boiling point of the substance. I know the boiling point of the substance for this equation is 90 Celsius. And I know this because when I look at the graph here, I can see that right here says 90 Celsius from when we were looking at a graph from temperature to time, it's 90 Celsius. And this flat line right here, once we get from a liquid almost up to a gas, between that is this flat line indicating the boiling point. This means that liquid has reached the highest point that it can reach before it starts turning into a gas. So right here at this boiling point, it's going to start vaporizing, and then once it gets hotter, it will start transitioning into a gas. So from this boiling point, that means we are going from a liquid to a gas when we reach this 90 Celsius point. Number 3, the condensation point of the substance. This is also 90 Celsius. And I know this because the condensation point is also the boiling point. The substance has reached a certain temperature that the gas has to change to a liquid. So because we are changing from a liquid to a gas, we are going to build up a form of condensation during this. And so that would make us have this condensation point and also the boiling point. Number 4, what is the freezing point of the temperature? So I got 55 Celsius for this one. And I know this because when transitioning from a liquid to a solid, that is going to start right at the freezing point, melting point. So melting point would essentially mean from the solid to a liquid. Freezing point is basically a liquid to a solid. And we would do this all at this line right here at 55 Celsius. What phases are present when the substance is 70 Celsius? I know that during this, when we are at 70 Celsius, we are not quite at the boiling point and we are not at the melting point. We are a little bit above the melting point and we are a little bit below the boiling point. So this right here would honestly just be the transition time between melting to boiling point. The temp is rising through here. So there's no necessarily a phase going on other than the temp rising, and then it's changing from a liquid to a gas not necessarily during this point, but it is starting to warm up to get to a gas boiling point. This one. We're also doing number 6 on this one. What phases are present when the substance is at 90? So at 90, we know this is the boiling point. During this phase, we know that the liquid is transitioning into a gas, and so it is going to be vaporizing right here. Number 7, what temperature does the substance exist only as a gas? So I know that because during 90, we are vaporizing, we are at our boiling point. How we know that this substance only exists as a gas is anything from this 90 degree up to this 120 mark. This is where it's going to be vaporizing, and then the water will be heated up enough to transition into a gas. So during this phase right here is where we will see that. All right, number 8, a gaseous sample. This has a pressure of 112 ATM and a volume of 250 L. If the pressure is increased to 150 ATM, what is the new volume of the gas? So we know the pressure is 112 atm, we know the volume is 250, and we know the pressure is increased to 150. So if the pressure is increased to 150, we need to find the new volume because the previous volume was 250. So we're going to start with the step one. We're going to start with Boyle's law, and that's going to be this equation right here, but I want to simplify this, so I'm going to rearrange it to this equation. V2 equals 1.12 atm times 250 L, and then we're going to divide that by 150 atm. We're going to divide the pressure, well, we're going to times the pressure by the volume and divide by the pressure that was increased. And we're going to get to 1.8666. For step 3, we don't want this big number right here, so we're going to round up to 3 significant numbers only, giving us V2 equals 1.87 L. The new volume being 1.87. Number 9. A 0.85 mole sample of a gas has a volume of 1.25 liters. If the 0.55 moles of gas are added to the sample, we need to find a new volume. So we know the mole beginning sample is 0.85, the volume of 1.25, and then we're adding the 0.55 moles to the sample. Now we need to calculate this new volume. We're going to use Avogadro's law, and this gave us this equation right here. I'm once again going to transition it into something a little bit more simpler. So V2 equals volume to the first power to the moles of the second power divided by the moles of the first power. So step 2, we're going to do exactly that. We are going to take the volume of it and we are going to times that and then divide it by the mole sample, and that is going to give us 2.0588, and then we're going to also round that again to the 3 significant numbers of 2.06, making the new volume of this 2.06. In the last one, a gaseous sample of 1.65 moles of gas has a temperature of 305 K and a volume of 275. What is the pressure of this sample? What I got for an answer was P equals pressure equals, or not pressure, my bad. We're just gonna start over. 1.65 moles of gas. We know the temperature is 305 K, and we know the volume is 2.75. So we need to find the pressure of this sample. Step 1, we're going to have our formula, and then we're going to input all of our information that we know for each one of these into this equation right here. And then we're going to move down, and we're going to move the constants, which is right here. This will be always a constant throughout this equation. And we're just going to move this to the left. It makes the equation a little bit easier to follow. And that's what we did right here. And then step 3, we're going to just multiply this entire equation. So after multiplying each one of these, we are going to get 2.75 times P equals 4184.0205 L kPa. After this, we're going to divide each sides, because this isn't one equation, we have to divide each one. So what we're going to do that is we're going to divide it by the constant. So 2.75 divided by 2.75, and we are going to take the answer we got right here, put this up top, we're going to divide it by the constant, and when we get that, we are going to get 1.521.462 kPa, making the pressure of this entire sample 1.521.462 kPa.